what? That's a volume. All right, what's the 185 torr? It's a pressure. Remember, we're learning 3 more gas laws today. And notice what it says down here. Practice what?
All mixed.
Your quiz tomorrow is all mixed. You got to be able to sort and separate these by tomorrow. All right, so that's a volume and a pressure. What's KPA?
Pressure.
That's a pressure. So we'll make that P2. And I'm asking you, what is the what? The new volume. So, oops, I got a V2. So, which law am I using from yesterday? Boyle's law. And I will tell you for the exam, you don't have to know if they're Boyle's or Charles' law. For my test, you got to know who's who. It's all part of being in an honors class. All right, V1, P1 equals V2, P2. So let me label what they were. Somebody tell me what the number was for the pressure. I remember 155 milliliters. Was it 185?
Yes.
Torr. And what was the KPA? 57.8.
Yeah.
All right. Now, before we can plug in, what's the one thing I told you to check yesterday?
Unit.
The units had to do what?
Be the same.
Got to be the same. Are they the same?
No.
So we can change them to any unit we want. They just have to match. We can make them both torr. We can make them both KPA. Or we can make them some other unit altogether. Which one did you pick?
18.
Okay. All right. She's going out on a living. Go check them all to ATMs. We can do that too. All right. Wouldn't have been my choice because you got more work, but we can certainly do it. All right. So 185 torr. Change it to torr. And ATM. What goes beside ATM? And 760. And believe it or not, Vetsabase choice is the one that will become the most popular in a couple days because the new laws that we will learn with the masses and the moles have to be in ATMs. So hers will become the most popular. It's typically not the most popular today and tomorrow, though. All right. And then 57.8 KPA. KPA on the bottom. ATM on the top. ATM gets a what? 1, and KPA gets 1 and 1.325. If any of you changed it to something else, I'll put those numbers up there too. All right, so 185 divided by 760 gives us 0.243 ATM. All right, so that's going away, and I'm going to have 0.243. And then 57.8 divided. Going to give me 0.570. So that's going away, and I've got 0.750 ATMs. Okay? Now, if you were like, nope, I want torr, and you kept 185 torr, you would have 433 torr here. And if you said KPA, you would have had 24.6 KPA. Okay? Just depends on what numbers you chose to use. Now, since we're Betsabe here and we used ATMs, my V1 is 155 milliliters. And because she picked ATMs, I need the ATM numbers. So 0.243 equals V2 times 0.570. To get V2 by itself, I'm dividing by 0.570. 0.570. And then I have V2. Now, if I'm anybody else and I chose to do it a different way, if I did mine with, let's just say torr, I have 155 times 185 equals V2 times 433. If I did it in KPA, I had 155. I had 24.6 equals V2 times 57.8. Okay? And that's how they'd be set up if I did those numbers. Questions? Now, what was the actual answer for V2 since I didn't calculate it? Anybody got it?
Where's my calculator?
What, Joe said?
Yep, I got 66. And the unit's going to be whatever is here has to be here, so it has to be ml.
I got 60.
67's fine.
I can get on this and go home.
I'm going to do the homework like always. All right, everybody got it? All right, question 2. What is 450 mLs? That's volume. What's 45 Celsius?
Temperature.
Temperature. What is 675 ml? Volume 2. And I'm asking you to find what? Temperature 2. And I want it in what unit? But can I leave it in Celsius to calculate?
No.
No, I have to calculate in what unit? Kelvins. So at the end, I'm going to change it back to what? Celsius. All right, everybody got it? All right, so let me erase here. So I don't have to keep changing the board back and forth 800 million times. All right, so V1, T1 equals V2 and T2. All right, so we're looking for T2. And V2 was what? 675. All right, do our volumes match? Shh. Do our volumes match?
Yeah.
All right, so what do I need to do to my temperature?
Change it down.
All right, so what do I do to do that?
45 plus 270.
We add 273. All right, so when I do that, I get 318 kelvins. All right, what's the formula we learned yesterday?
Oh,
V1 over T1 equals V2 over T2. Everybody got the formula? All right, so V1 is 450 over 318 equals 675 over T2. Now, I told you yesterday, if you've got great math skills, solve it any way you want. I'm not going to solve it any way you want. I'm only doing it one way in class. I cross multiply. So 450 times T2 equals 318 times 675. So to get T2 by itself, I'm going to do what? I'm going to divide by 450. Now, when I solve for T2, all I have left is to check my units. They have to match. So whatever is here had to match with what's there. So what is my unit in? It's in kelvins. Now, the question, if it doesn't say, find something else, if it just said, what is the temperature? I'd stop there. My temperature will be in kelvins. The only reason I'm changing it this time is the question said, what is the temperature in Celsius? If it doesn't say put it in Celsius, I would never put it in Celsius. Okay? Most questions won't say put it in Celsius. Most will say what is the temperature, and I would stop there and leave it in kelvins. But because it said what is the temperature in Celsius, we have to fall back on our K equals C plus 273 and solve. So 477 equals C plus 273. So I do what to get the answer? Subtract 477 minus 273, and I get Celsius equals 204 degrees C. Questions about how to do that? Anybody?
Well, I'll do this real quick.
Sure. All right, let's look at homework. See what kind of questions, if any, you have on homework, if you did any.
What's hard?
Yeah. Figure out like-
Really?
Yeah, that, I don't understand it.
Oh. Okay. Well, let's look at homework then.
I mean,
All right. Question number 3 was just converting pressures to practice because, like I told you, some of the questions today are going to require you to do unit conversions. So 3A should be 125 torr. Everybody okay with 3A? Okay. 125 torr. 3B, 3.2 times 10 to the 5th pascals. Now, if you didn't put it in scientific notation, yours is probably like 32,000. No, that would be the 4th. 320,000. And 3C, somewhere around 40.4 millimeters of mercury. Any issues with number 3? That was number 3. And yes, I did because you decided to go get water and no, I'm not going back over it. Number 5, 140 milliliters. Now that is probably rounded for significant digits. So you might have something different, like 140 something milliliters. Anybody have something different? Sarah Lee, what'd you have? 141, okay. So that was probably rounded. 6, 38.8 kPa. Number 10, 121 kelvins. And number 11 is the one I told you to substitute in 273 for the word at standard temperature. Should be 406 milliliters. So which ones do I need to do?
number 6.
All right, number 6 says a flask containing 155 centimeters cubed. What's a centimeter cubed? Is it a volume, a temperature, or a pressure? It's a volume. All right, so V1 equals 155 centimeters cubed. All right, has collected under a pressure of 25.5 kPa. So what's 25.5 kPa? So what is 22.5 kPa? Pressure 1, all right. So if I keep reading, it says what pressure would have been required in order for the volume of the gas to have been 90.0 centimeters cubed at constant temperature. So what's 90.0 centimeters cubed? All right, that's right. Centimeters cubed a minute ago you said was volume. So make it volume 2. And it says what would the pressure be? So we're looking for pressure 2. Do the units match? Yep, so it's just a plug and chug at this point. V1 P1 equals V2 P2. So volume is 155. Pressure is 22.5. Volume 2 is 90. Pressure 2 we don't know. So to solve, we're going to do what? Exactly. And you get whatever I called out. What number was that? It was 6. 6 answer was 38.8. Anything else? Sure. So the first thing you read in the question says at standard temperature. What did I tell you at standard temperature was? We're going to talk about this in just a minute, but what does the word at standard temperature mean? What did I say yesterday? As soon as you read the word at standard temperature, it's 273 Kelvin. Now it tells you this on your reference table, so if you forget it, it's in that top box on your orange table. So just write 273 K. All right, if you keep reading the question, it says has a volume of 275. So this temperature has a volume of what? 275 milliliters. All right, and then we had another sentence. If the temperature is increased to 130 degrees Celsius. So the temperature is increased to 130 degrees Celsius. and pressure is held constant, what is the new volume? All right, so are we good to go on the units? No, what unit's not okay? The Celsius. So 130 plus 273 makes it 403. All right, so what formula are we picking? Charles. So V1 over T1 equals V2 over T2. So what's my first volume? 275. What's my T1? Equals. What's my V2? Okay, and what's my T2? Exactly. And we're going to cross multiply. So 275 times 403 equals 273 times V2. So to solve now, how do I get V2 by itself? Pretend you're in math class and you need V2 by itself and Mr. Krotz is staring at you. How would you tell Mr. Krotz you get V2 by itself?
Well,
Yes, yes, sir.
I need Jennifer Garcia.
Okay. So you're going to divide by 273, and then you're going to divide by 273. So V2 equals, multiply and divide, and your unit has to match here. So it'll be millers. And that would have been, what, number 11 was 406. Anything else in the homework that's bothering you, or those two laws? Because the next two work almost identical to these two. The process is the same. Can I do what? 3B? Okay. So 3B gave you 2.48 times 10 to the negative third ATMs. No, that's the wrong question. That's B. That's number 2. 3.2 into PA. Okay. So ATM goes on the bottom. PA goes on top. So what's the number for ATMs? No. Yeah. What's the number for PA? That's because it's in your notes and you got to memorize it. It's the only one not on the reference table. It's also on the worksheet I gave you yesterday in case you didn't write it down. 1.01325 times 10 to the 5th. Oh, there you go.
It was your gift.
And then multiply that. Anybody else? That's about it. Shush. Anybody else? Question? On the homework or what we did yesterday before we add in 3 new laws?
Could we do one more example?
No. Because the 2 we're going to do next work just like these laws.
Okay.
When we get down here, we're going to do more examples. All right. If you will, find your notes so that we can learn 2 more. And then the only one that works different today is Dalton's Law. And I'm even going to be ever so kind to y'all and trim that one. And when we take the test, there's 1 2-point question on it. And you're going to need to remind me to give you the answer to that question because I'm even going to skip it and not teach that topic. Because if you forget, you're going to get the answer wrong. So you better not forget to remind me. All right. All the way to Gay-Lussac. See about here. Yep. All right. We should be able to cruise through Gay-Lussac's law pretty quick based on what we did yesterday. All right. Gay-Lussac's law is pressure and temperature at constant volume. Now, this would be the example of the aerosol can thrown in the fire. So, if you have any type of cylinder that has a gas inside of it. And the can or the gas cylinder cannot expand in any way. Okay? And the temperature, let's just say, is around 25, which would be fabulous in here because we wouldn't have to have our coats on because it wouldn't feel like we were all freezing to death. All right? And we raised the temperature on the gas. Thermometer looks more like a pickle there. So that the temperature on the can was closer to 85. What's going to happen to the gas molecules inside of this cylinder? Okay? So the particles move faster. And when they move faster, what do they do more? That's right. They collide more often. Now, what did we say yesterday those collisions caused to happen? All right, they hit the walls. All right, so if they hit the container walls more often, what does that mean we've increased? What increases if we hit the container walls more often?
Volume.
Remember, volume is staying constant. So what's increasing if we hit the container walls more often? There you go. Pressure is increasing. So, as that temperature continues to increase, those collisions become greater. Eventually, what will happen to an aerosol can or any cylinder if the heat isn't backed off? It explodes. Which is why most aerosol cans have a temperature, I think, of about 52 degrees Celsius. It tells you not to go above that. Okay, so particles will move faster, they collide more often, they hit the container walls more often, and pressure increases. Now, you can see here, what did we do to temperature? And what did we say here? All right, so what's the relationship?
Inverse. No, that's
Okay, so pressure and Kelvin temperature are directly proportional at constant volume. And again, I'll write in parentheses, and moles. Because again, we're not changing moles today. Moles will be tomorrow. Now, the formula for this one is volume's constant, stupid. P1 over T1 equals P2 over T2. Pressure 1 over temperature 1 equals pressure 2 over temperature 2. Phew.
Can I put my light on real quick?
All right, do we have it? Everybody caught up? Is that a yes? All right, here's your sample. Let me see which one's shorter. That one's shorter. Right, that one. I'm gonna make these Saturday school contract copies while y'all running. Write that down so everybody has a sample. Remember, these are your only notes.
We met us going. I do too.
Like, I remember like what's
Yeah, I was like, oh, and then, you know, he
We had,
Write down the sample.
What?
Did you write down the sample, Landra? Okay.
what part is
We don't.
Try to measure a copy in case you want to go.
wait. Can we go there? Is Saturday school just like, can we use Saturday school for other things other than like makeup days and stuff like
You can use it for credit recovery. But credit recovery is for first quarter.
Did you say that?
And I haven't written you one for my class. So it's not going to do you a lot of good in here. These can go hard. All right, we caught up?
Wait.
What's that, 203? Oh. I couldn't hear a question, bro. I be running the whole time.
All right, so when you look at the question, what is 1.8 ATMs?
Pressure one.
That's pressure. So that we're going to might as well make that pressure 1. So P1, you change colors. All right, so P1 is 1.8 ATMs. All right, after we read that, it says at, again, 20 degrees Celsius. So that 20 degrees Celsius has to stay with the 1.8 ATMs. That at is a connecting word. Remember, they're coupled or paired when you're working these in a little bit. So we're going to make that T1. If we keep reading, what do we see 1.9 ATMs as? P2, all right. And what did that ask us to find? All right, so Celsius temperature. So this will be another one we're going to have to change back. All right, are we good to go? Are the units in what we need them to be? A, do they match? And number 2, are they in the correct units? So are they matching? Yes, the ATMs match. So if we check here, ATMs, we match. I don't have to convert. My temperatures, are they in the right units?
Nope.
No. So what do I need to do there? Add 273. So I get 293. All right. Now all I have to do is what? Plug and chug. Now, this point is what I told you yesterday is really just your math skills. This is not a chemistry skill. So that's the formula. P1's 1.8. T1 is 293. P2 is 1.9. And T2 we don't know. So I'm going to cross multiply. 1.9 times 293 equals 1.8 times T2. So to solve for T2, I'm going to do what? Divide by what? 1.8. Anybody got the answer for me?
Yeah, it's about 309.
309?
It's subtract that.
All right. And because this particular question wanted it in Celsius, that's in Kelvin, I've got to do what? Subtract 273. So temperature 2 is going to be what in Celsius? It's what? What'd you say? 96. Sorry, with you chewing on your straw back there, I couldn't make it out.
He said 36.
He said 36?
Yes. Oh, I thought you heard me.
Clearly not.
Yes, you like you. The doctor's on me ice cream. It is like
What was it?
He said 36 that time. I thought he said 96. All right. Do we feel pretty good about Gay-Lussac's law?
no.
No. They all work the same way. Do you want to try another one?
Pretty much what we need to know is just the definition.
You need to be able to solve. All of these are going to be math problems on the test. There are 10 multiple choice on the test, and 80 points is solving word problems. Next week sometime. I don't know exactly.
Roll out some lotion.
Best guess Tuesday or Wednesday. I can't say for certain. You might be AP testing on the day of the test. I can't fix it for you. I cannot fix it. I cannot fix it. All right. The combined gas law. I'm not going to explain the combined gas law other than to tell you it is a combination, yep, of Boyle's, Charles, and Gay-Lussac's, yep, law. It's a combination of all three. So here, the only constant is mass or moles. Okay, that's the only thing that's not going to be in this formula. So, this one is also on the reference table. And I'm going to show you something cool about this one that will help those of you who struggle with formulas to learn the last three formulas. So catch up with me, and maybe I can help those of you who don't know the formulas learn them. And then that only leaves one other new formula before we talk about moles.
Don't. You say it's already.
All right, everybody got it?
No,
All right, so let's say
what did he say?
tomorrow on the quiz, that you're reading the quiz and it says temperature's constant. But you're like, I forgot the equation as well. You can look up the formula on the orange reference table and take temperature out because temperature's constant. And whose law are you left with? That would be Boyle's law. Okay, it's the exact same formula that we learned yesterday for Boyle's law. All right, if you read a question and it tells you pressure's constant, pressure's constant means you don't need pressure in the formula, right? Pressure's constant would be Charles' law. Just take pressure out. If it tells you that volume's constant is Gay-Lussac's law. That's the one we just talked about. All you have to do is take volume out, and you have Gay-Lussac's law, which is the one we just learned. If nothing is constant and everything is there, then you leave all of them in, and you have the combined gas law. All right? But this is the only formula that works this way. Okay? So all three formulas that we've learned yesterday and today all come from this formula. You got it? Now, the biggest mistake that's made is Boyle's law. I'm going to show you something. On the quiz tomorrow and on the test, more people write Boyle's law this way and they lose half their points. Is Boyle's law written this way? No. Boyle's law does not have a denominator. It's all in the numerator. Okay? The only thing that's in the denominator is which variable? T. Okay? So remember that tomorrow. Don't try to force volume or pressure into the denominator. All right. Write your sample down. And then we're going to solve a couple of these because more people have trouble with this one with calculator than anything else. And then we're going to talk Dalton, and then we're going to practice. Salma, come on, get it written down.
It is real color. Oops. That was hilarious.
All right, we have time?
No. Well,
Good Lord, it's only 3 lines this time.
but I was going to work.
Oh, I was going to work it with you. Some people struggle with this. If you are doing the work, just keep going on your own. All right, so when you look at this, the only difference in this question is these are in triplets instead of pairs. So if you know what you're doing like Liliana, just keep going and then check your answer when I finish. All right, so this is pretty straightforward. So when you look at it, the hardest part for most people is making sure the units are lined up with the correct variable. So a liter is a what? Is it a volume, a pressure, or a temperature? It's a volume. So make sure the 50 liters goes with the volume. The 25 degrees Celsius is a what? It's a temperature. So put it with a T. And the 820 millimeters of mercury goes with the what? What's the millimeters of mercury go with? It's the pressure. Now, all you have to do are match them up on the other side and make sure your units all match. So we got a V2, a P2, and a T2. So what's my volume? Well, it says what volume, so I don't know it. What's the 650 millimeters of mercury? Okay, that's the pressure. And then the 10 degrees Celsius is a what? All right, so the first thing I do is check to make sure my units match. Well, this one doesn't have a matching unit. It's in liters. So that tells me my volume is going to turn out to be in what? Liters. My millimeters of mercury, they match my millimeters of mercury, so I'm good to go there. But my temperatures, can I leave them in Celsius? Nope, so I need to change those to kelvins. So 25 plus 273 is 298. And 10 plus 273 is 283. Even I can do that in my head. All right, so all I got left is plug and chug. So V1, P1 over T1 equals V2, P2 over T2. So let's plug in some numbers and see where we get. So 50 times 820 over 298. And then V2, 650 and 283. Is everybody okay with how I did what I did so far? Okay? Now, I'm going to cross multiply. So, 50 times 820 times 283 equals 298. V2, 650. Now, the only difference in this question and the ones we've been working is how many numbers are with a V? We'll say, I only see two numbers with a V. So this time, instead of dividing by one number, I'm dividing by how many numbers? I'm dividing by two numbers. I'm dividing by 650, and I'm dividing by 298.
But can you not multiply them together?
I can. I'm not going to. Because, again, you remember we talked about the quiz and the test, and y'all want maximum partial credit if you do something stupid? If you write down bizarre numbers on the quiz and the test, do I know how you got it? No. Now, you can do that on your paper bet today. There's not a problem. You can multiply and do anything you want to. Remember when I told you, those of you who have superior math skills, you can solve it and do it any way you want to. Okay? And I'm not going to complain. But if you go from here to a wrong answer, it's a standard deduction minus whatever. If it's a 20-point question on a quiz, it's probably minus 10. Okay? I'm not hunting for the mistake. I'm not punching on my calculator and trying to figure out where your error is. It's just a standard deduction. But if you've solved and shown me your math to get there, you get more points because you've shown me your steps. Those weird numbers, I don't know where they came from. Okay? That's the only reason that I do it this way is so you can see how I got there. So the more you show me on paper, the more points you get because you've shown me how you got there. But I'm not going to pick up my calculator when I'm grading these in the afternoon and trying to figure out how you got there. Okay? So that's completely up to you. But if you want to double check and you make sure you got the right answer and you don't want to show me all that, you don't have to. Okay? What? So we get 59.9. Or you can round it to 60 if you prefer. Did you get that?
Yeah.
Okay. So as long as you can do that without error, then I don't care if you don't show me all those steps. It's fine. Okay? Everybody good? All right. Because unfortunately, not everybody in here is the same level of math student. Some of you are in calculus. Some of you are in like math 3. So if you can solve this every time correctly, I don't care how many steps you show me on the paper. But those of you who struggle really should show more steps. Now, let's find me the answer real quick. And then we're going to talk Dalton. All right, find me the answer. You don't have to write it. You got a sample. Just find me the answer.
You want to know something? Cole?
Gabriel, you too. What?
You got something-
What? Do I have something?
You got something cold on the road, like ice pack in the fridge or something like that?
I don't keep ice packs around. All right, find me an answer. This one's an easy one. Straightforward. We're going to talk Dalton, and then we're going to mix them up. What? All right, who has a question? Y'all have time to get started and get stuck. Anybody need my help? Anybody? You got it, Brian? Yes. Anybody else? Got it? Ira, you got it? Any help?
So,
That's the way you got it?
Yeah.
Okay. Sal, what about you?
I have the first part.
You still working? You stuck? Where we at?
I'm waiting on you.
Waiting on me? You ain't called me.
right. She'll be there.
Am I supposed to know?
What do I go?
You gotta change those two Kelvins, and then let's plug it in.
How you changing?
273.
So that's 273, right?
Mm-hmm.
I think the answer may be your mama.
There are no answers in here that are your mom. Ever. I'm pretty sure there are no answers in here that are ever your mom.
My mama
right, I
is
got it.
always right.
Okay? So now take the formula and plug in your information. You already got that language. This is your formula, plug your information in.
Yeah. Oh, whoa, hold on, wait a minute.
Take that. Go to the question mark.
Miss Wall.
All right, so you've got, according to the formula, B1, so 27.5.
Yeah. I got a big
All right,
one.
times P1. P1 is 740 over
That's
T1. T1 is 295.
You don't even want to know.
Equal.
How many digits did you have?
P2.
It's like 25.
P2.
I got 26.
What'd you get?
Okay.
I got like,
All right, so now
What
let's
you
solve.
read the number?
I got like 14.
Yep. Solve P2.
This one,
Yeah,
can you tell me?
solve.
Can you tell me right this one?
Am I doing this right?
Is that what the answer is?
That is not right. You can't leave it in Celsius. You gotta change it. Oh, 295, sorry, that looked like 245. Where's your 9? All right, so that's 295. And then, all right, hey. Oh, that's a temperature. All right,
Alright, bro.
says degrees Celsius.
I got two of that.
Temperature should be down there. That should be a question mark. So, and then add 273. Why are there crazies flying around the room?
Yeah, Drake.
Some of the trash we don't want.
You know Drake? Oh, no, I got the inside guy.
All right, now keep going. You'll be fine. All right, anybody else?
Me.
Where are you?
I don't know why I did That's definitely.
Dear God, no.
That's right, Drake. That's right, Drake. The Chronicles of Bond.
I got a big number 10.
So I'm gonna plug it
Oh, I got like.
I guess here.
This one.
Let me see what number. Did you get the same mistake?
You probably got 14 billion.
Was it because 14 billion?
Bro, what I do? I'm not showing you that. What I do?
Here.
What number do you
All right, Becky, you got it?
get? Where'd you get
All right, so you'll make sense of that. Divide. And then 755, and then there's a 735.
Oh, I got 26.
That's 755. You got to go more.
No, none of
Y'all good? Y'all got sound straight? All right, what'd y'all get?
26.
26?
Okay.
What unit you put on it?
it.
Milliliters.
Yeah, million.
All right?
Like this. What is it?
I don't know, you don't put that number.
I got this.
You got him?
Yeah, hold up.
While Tevin is getting high, we'll write that down.
All right, bro, so. All right, bro, so another little formula thing made by D1.
What are you doing? He has all the work.
No, but he messed up some of it.
No, he did not.
He had T up here. He had like T1. I'm like, what?
No, he didn't.
That was T1. Yes, it was. That was T1. I'm not blind.
That's why I do it on the board.
He blind. He blind. I think I
Go away,
just-
sexy. Go away.
Oh, my bad. I'm
Yes,
sorry.
I did.
See? It's not that hard.
Now put the work back.
That's like, well,
Look.
I had to do
Wait,
it.
what'd you
This
say?
is funny.
Yes, you know.
I'm gonna do that and take you with the
So
ATV.
hey.
Look, we probably gonna just look at it.
Ah,
All right, that's one.
yes, so cross multiply. So you get 27.5 times the 740 times the 288.
Right.
And then that's going over there. So you got 295 times V2 times 755. Now, we need V2 by itself. So we'll divide by that's right. That means you gotta divide over here by those two. So 295 and 755. Now, the common mistake that's made when people put it in is they divide by this first one and then they multiply by that. When you punch it in the calculator, if you say divide here, multiply these three, multiply the top, and then divide by what's here, and then divide by that one. So when you're punching in the calculator, multiply across the top, divide by this, divide by that.
She was everything was, I swear.
With the exception of high road, does everybody have what's on the board?
Yeah.
Yeah.
What happens when you put a little in my eye?
Yeah, 26.
The waves bounce off. It reflects them.
Wait, so, but I'm stuck part-time in, library.
I still remember that. I was walking on.
But it like, it did, but like, it was like, it started, it was like this little flash of light. It was just like, light distraction.
And I looked, I was like,
I thought the light was about to explode. I got scared, so I ran away. I don't have to take part of that.
confused, like.
I know what happened.
Why can you put aluminum foil in the oven, but you can't put it in the microwave?
Because
71.
My culture
We're using
radio waves.
Yeah.
All right.
I'm there.
Now, we use shorthand in the gas laws a lot. All right. One of the ways that we use shorthand. Shut up. Will you hear me talking? That's your cue. Stop. One of the ways. Yes, I already said you should have this written down, except for Hyro, who I was helping. One of the ways that we use shorthand is to use STP a lot. All right, you're going to see this on the practice sheet that I'm going to give you in a few minutes. You will see it on tomorrow's quiz, at least in one question. Now, STP means standard temperature and pressure. Now, standard temperature means 273 K, which we talked about yesterday, briefly. Standard pressure is 1 atmosphere. Now, you don't have to memorize it. It's on your orange sheet in the first block at the top on the first page. It's probably 2 or 3 lines down, Trent, since you're looking at it. It's not very far down. Now, sometimes, like last night's question 11, it just said at standard temperature. So if it just says at standard temperature, you just use the 273 Kelvin. Some questions might just say at standard pressure. If it just says at standard pressure, you just use the 1 ATM. Now, if it says STP, you do what? It says standard temperature and pressure, so you use what? You use both. Okay? Everybody got it? Now, we're going to talk Dalton's law. Now, Dalton's law of partial pressures, I told you a minute ago, we're going to trend. So when we do the test, again, there's one question in the multiple choice. Somebody needs to remind me that I need to give you the answer to. So you get 2 free points on the test. Nobody should score lower than a 2. So we shouldn't hit the low of the 1 year where I gave a 0 on the test. Now,
Wait, did they cheat or did they actually earn a 0?
they earned a 0. They didn't know anything. Now, the total pressure of a mixture of gases. The total pressure of a mixture of gases, Gabriel, wait, Bryce, is equal to the sum of the partial pressures of each individual gas. So this would apply to a container of gases. So assuming that, let's say we had some helium gas, some oxygen gas, and some nitrogen gas. All of these gases are flying around the container and bumping into the container walls and each other, right? they're all going to exert pressure. So all Dalton is saying is the total pressure of that mixture is equal to the sum of the partial pressures. So if I add the helium and I add the nitrogen and I add the oxygen, I can get the total. That's all Dalton is saying. Okay? The total pressure of a mixture of gases is equal to the sum of the partial pressures of the individual gas. So if you think about a container, such as the one I've drawn here, that has three gases. All three of these gases are moving around, hitting each other. They're hitting the container walls, right? So if we add the pressure of helium, we add the pressure of nitrogen, we add the pressure of oxygen. All three of those added together will give us the total pressure inside of the container. All right, so the formula that I have written there, PT stands for what? What do you suppose this T stands for? This says pressure total. Okay, PT stands for pressure total. Pressures 1, 2, and 3 stands for the partial pressure. Okay, P total and partial pressure. Now, these little dots mean that you could do this for the number of gases you have. Now, since this gas cylinder only has 3 gases, I would only need 3 partial pressures. But if I had 5 gases, I would need how many of these P's? I would need 5. So for this particular drawing that I've made, my formula would look like P total is equal to the partial pressure of helium plus the partial pressure of nitrogen plus the partial pressure of oxygen. So if I wanted to know the pressure inside of that gas cylinder, I just need to add the pressure exerted by the helium plus the pressure exerted by the nitrogen plus the pressure exerted by the oxygen. If you add all those pressures together, you know the total inside the canister. Does that make sense? Yes or no? Okay. Sort of like if I shoved you all in the box and I knew how hard everybody was pushing on the box, I'd know the pressure exerted on the box.
So you just made it sound very scientific?
Huh?
You just made it sound very scientific?
Pretty much. This one's pretty self-explanatory. Now, the nice thing about this one is you're only going to have what kind of things in it? Pressures. There will be no volumes. There will be no temperatures. So the only catch to solving these is what all these pressures have to have in common. What about the units? Need to be the same. Okay? Everybody caught up? All right, so here's our sample. All right, what is the total pressure exerted on a container if neon has a pressure of 2.5 atmospheres, hydrogen exerts 653 torr, and nitrogen exerts 152.3 kPa. And I give you a moment to write before we solve.
So.
You gonna live out around Ford Street?
What street?
Ford.
What the bullshit?
I don't know, there's apparently a small sinkhole.
What?
I got a notification from dispatch.
I don't fucking
That's why I was
Did you
asking.
really?
Wait, which is it?
There's a sinkhole on Ford Street.
Ford?
Ford.
Did it fall on you?
I don't even be on Ford Street. I don't live on this side of town.
Let's go for a walk.
It's not huge, but it is a sinkhole. All right. So the question asks us to find total pressure. Now, sometimes students get stuck when this is all mingled in with the other questions. But what do you notice is missing in this question? What do you not see any of? No volumes and no temperatures. There's no degrees Celsius, no kelvins, no milliliters, none of that. All you see are KPA, torr, and ATMs. That's it. That's all you've got. And it asks for total pressure. So I don't think you'll have a huge challenge in identifying this. So pressure total is pressure 1 plus pressure 2 plus pressure 3. Now, our challenge is that, I heard somebody say it.
They don't have the same pressure.
There you go. They don't have the same units.
That's it.
When you look at them, what do you notice about all of them? They're all what? They're all different. Now, I could have said in the question when I said find the total pressure, I could have said find the total pressure in atmospheres, and you'd have to do it in atmospheres. I could have said find it in torr, but since I didn't specify, I just said find the total pressure. Does it matter what unit you use?
No.
Pick one. Do I care? I will tell you now on the test that y'all will gravitate towards ATMs because the formulas we will learn tomorrow will push you towards ATMs. But truthfully, I have no preference today. So it does not matter. Okay, so if we do atmospheres, off to the side somewhere, you're going to need to change torr into atmospheres. What number goes with torr? 760. So 653 divide 760, 0.859. And then take the 152.3 KPA, change KPA to atmospheres also. So 1, and what number goes with KPA? So 152.3 divide 101.325, and that time I get 150 or 1.50. So 2.5 plus 0.859 plus 1.5, so I get 4.85 ATM. Questions?
Because they wanted to give us this, and just specify what kind of like, which one, like, atmospheres towards it. So which one would you prefer?
It would matter. So tomorrow on the quiz, let's say I asked for one of these, and I just said, what is the total pressure? I would grade any unit. My answer key will be, I would have all three of them calculated. Because if I don't specify, I will not hold it against you. In the next unit where we're going to learn how to use mass and moles, Some formulas can be done with, or problems can be done with multiple formulas. My answer key looks like Chinese because I haven't worked multiple ways because you can do it with multiple formulas. So I won't criticize you based on which way you choose to do it if I don't specify it. All right, we don't want that. I told you I was going to cut that. Questions, Leanna? All right, so are we ready to try to practice mixing them up? All right. I don't need, what time is it? Yep, I'm not going to need any more of that today. Stop.